Hi, well, I'm Tracy Crosbie. I'm a reader in sustainability in the built environment at Teeside University in the School of Computing, Engineering and Digital Technology. For those of you that might not know what a reader is, it means I'm almost a professor, but I haven't quite got there. Hope to do so before I retire. So today I've been asked to talk to you about north of the Tyne emissions now and in the future. So I'm going to talk very little bit about what carbon emissions are, why we're concerned about them, why it matters, where they come from, mention the UK's carbon reduction targets and talk to you about where carbon emissions come from specifically in the north of Tyne. So you can start thinking about where action is needed. I've been thinking about these things since I was considered a tree hugging hippie at the age of 15, and it's what's sort of driven my thinking throughout my career. So, and I hope I don't bore you too much or get too academic. Okay, so carbon emissions. In its most basic form, carbon is just a chemical. It's a chemical element, and which means it's a substance that cannot be decomposed into its simpler substances by ordinary chemical processes. The elements themselves are fundamental materials of which everything is made up of. In fact, it's the most common element for life on Earth, from the air we breathe to what we grow to the chemical makeup of our own bodies. Literally, it's the basis of life. So why are we concerned about them? Well, when we talk about carbon emissions, we're focusing here specifically on carbon dioxide or CO2 emissions. It's naturally released into the atmosphere in many, many ways. The largest source of natural carbon emissions is sort of from the exchange of carbon dioxide between the sea and the atmosphere. Animals and plants also emit CO2 through processes of respiration. And when plants and animals decompose, the organisms within the soil respire to produce energy and emit even more CO2. But nature tends to keep most of these in balance. Plants absorb CO2 through photosynthesis, and oceans absorb just about as much carbon dioxide as they let off. So a carbon cycles through our air, water, the soil is a continuous process of life on Earth. But we don't play by the same rules as nature. So when we extract and refine and transport and burn fossil fuels like coal, gas, oil, we release extra carbon and other greenhouse gases into the atmosphere. We cut down loads of trees, which are CO2 absorbing, to make way for new farms and developments and for lumber and wood to create new things. When these trees burn or decompose, they emit CO2 emissions, and by removing trees and forests, we also remove the natural systems that absorb and store carbon. When we add additional CO2 to the mix as humans, it's just that nature can't always deal with this and isn't dealing with it at the levels that we have at the moment. I'm not going to go all technical on you here. So make it greenhouse gases that absorb radiation and prevent heat escaping from our atmosphere. This creates excess heat, disrupting weather patterns and higher global temperatures and other changes in climate. Now, there are other greenhouse gases, nitrogen, methane, and even water vapour, but CO2 is by far the largest contributor to greenhouse gases. Around 70 to 80% is made up of CO2. So, where do we as humans make carbon or increase carbon? Since the Industrial Revolution, human sources of carbon dioxide have been growing. So this is human activities such as burning oil, coal, gas, as well as deforestation, that's cutting down all the trees, are the primary causes of increased carbon dioxide in the global atmosphere. Around 90% of all human produced carbon dioxide emissions come from burning fossil fuels. So that's coal, natural gas and oil in the main part. The remainder comes from clearing forests and other changes in the way that we use land, and industrial processes such as cement manufacturing, which I'm going to talk about a little later on. So, as I mentioned, by far the largest human source of carbon dioxide emissions is from the combustion of fossil fuels. Burning these releases energy, which is most commonly turned into heat and electricity or power for transportation. They are used in power plants, cars, planes, and industrial facilities and factories. The three types of fossil fuels that are used the most are coal, natural gas and oil. And coal's responsible for around, 40–45% of carbon dioxide emissions from fuel combustion. Around 36 is produced by oil, and the other 20% comes from around natural gases. Now, coal is a big problem. And you hear that everybody is talking about reducing the amount of coal that's used. And this is because it's the most carbon intensive fossil fuel, yeah? For every tonne of coal burned, about 2.5 tonnes of CO2 are produced. All of the different types of fossil fuel, so coal produces the most carbon. Because of this, its high rate of coal use is the largest fossil fuel source of carbon dioxide emissions. Anything involving fossil fuels has a carbon dioxide emission price or ticket. So burning these releases energy, but carbon dioxide also gets produced as like a byproduct. This is because almost all the carbon that is stored in fossil fuels gets transformed into carbon dioxide when we use those fuels. The three main economic sectors or areas that use fossil fuels are electricity and heat, transportation and industry. The first of these, two of these, so that's electricity and heat and transportation, produce around 2/3 of global carbon emissions. So let's think about the electricity and heat sector. Electricity and heat generation is the economic sector that produces the largest amount of human-made carbon dioxide emissions. I must stop saying man-made, I don't like it. This sector produces around 40% of fossil fuel related carbon dioxide emissions, roughly. And around globally, this sector relies heavily on coal, which, as I've mentioned, is the most carbon intensive of the fossil fuels. The industrial, residential and commercial sectors are the main users of electricity, covering around 90% of usage. Industry is the largest consumer of these because certain, manufacturing methods or processes are really energy intensive. So specifically, that is the production of chemicals, iron, steel, cement, aluminium, as well as the paper, as well as pulp and paper. And these account for the greatest majority of industrial electricity use. The residential and commercial sector, so that's houses and shops and offices are also heavily reliant on electricity for meeting their needs, for heating houses and lighting them. And particularly this is in the area of lighting, heating, air conditioning and appliances. And one of the issues that we have in the residential sector now in the UK is a growing amount of air conditioning and an increasing number of appliances in our homes. So while we're making some progress to improve, if you like, the energy performance of our housing in terms of how much energy we need to heat it, that's being offset by using more air conditioning and more stuff that uses electricity in our houses. So if we turn to the transportation sector is the second largest source of human carbon dioxide emissions. Transporting stuff, goods and people around the world produces a large amount of fossil fuel related carbon dioxide emissions. And transportation is very energy intensive as it uses petroleum and petrol-based fuels, gasoline, diesel, kerosene, etc., almost exclusively to meet those needs. Since the 90s, in fact, transport emissions have been really growing and have increased by something like 50% in the last few years. And if we start thinking, oh gosh, here I'm going back to cars, I'm going to upset everybody. Road transport accounts for something over 72% of carbon dioxide emissions from transport. So that's cars, freight, vans, lorries. These are the main sources of emissions for the whole of the transport sector. And emissions from these three have steadily grown. Apart from road vehicles, that's cars, lorries and trucks and things, the other significant and important sources for this sector are shipping and flying, global aviation. So shipping, marine shipping produces about 14% of all transport carbon dioxide emissions. You might think this is strange because there's not that many ships in comparison to cars and aeroplanes, you might think. But while there's a lot less ships used in the than road vehicles and cars, say, used in the transportation sector, they burn some of the dirtiest fuels on the market, very unrefined fuels. And because of this, shipping is responsible for something like 1 billion tonnes of carbon dioxide emissions. And this is more than the carbon emissions from some countries like Germany, South Korea and Canada, for instance. So this is something that we need to think about. Oh, now I come to flying, and we all like our foreign holidays. I myself love going to Greece. And this is one of the issues that always gets me, because as an academic, in order for my CV and everything and all the things I'm supposed to do, and I work on and run large international projects, and I'm always flying from A to B to C in order to present or go to meetings. And I think one of the good things, if we can say anything good has come out of the pandemic, is that we've now learned that we really don't need to fly this much, and I really hope that it carries on. But to get back to the point, aviation is also the most carbon intensive form of transportation. So its growth comes with a very heavy impact on climate change. So I think there was a figure, something like 62% of the emissions from flying is from international flights, with domestic flights representing about 35 to 40%. In recent times, aviation has been one of the fastest growing sources of carbon dioxide emissions, because we all fly up now. I mean, flights are really cheap. I saw flights to Malaga for £39. So it's really, really easy for us to just jump on an aeroplane. So emissions caused by transportation of people and goods has also grown so rapidly that it has come to be greater than the emissions from industry. And it has a huge impact on climate change. This started in the 1990s and has continued to increase ever since. The emissions caused by the transportation of goods, that's the stuff we buy in the shops, the supermarkets and everywhere. They're where do the carbon emissions come from north of the Tyne? Because to work on reducing carbon emissions, we need to know exactly where they come from. So I've got some figures here from north of the Tyne. So this includes Newcastle upon Tyne, North Tyneside, Northumberland and North Tyne local authorities. So about 32% of the carbon emissions, they come from housing. So that is our homes. And to do anything about this, we need to reduce the amount of energy that we use in our homes. And most of the energy that we use in our homes is used for heating and hot water, as I touched on earlier, yeah? And another issue that we have with housing is that we have some of the oldest housing in Europe, because not as much of our housing was destroyed in the Second World War. And also we have a large part of our housing sector is privately owned, and it's a lot more difficult to encourage people to improve the heating systems and insulation in privately owned homes. Transport, about 35% of the carbon emissions come from transport in north of the Tyne. So we need, I'm sorry, to move away from cars, well, at least from petrol cars, to public transport, and also increase the amount of people using electric cars, and also just work closer to home. And in industry and the commercial sector, accounts for about 33% of carbon emissions in north of the Tyne. So we need to look at how we can move further towards energy from renewable sources and carbon capture. So the amount of energy used by renewables is the amount of energy generated by renewables is increasing, yeah. So hopefully in the future, for instance, if we have more electric cars on the road, the energy that drives those cars will come from renewable energy sources. So by renewable energy sources, I mean wind power, I mean solar power, I mean geothermal, and possibly wave power in the future. And carbon, the other thing we can do to offset the amount of energy used by our industry, which north of the Tyne is about 33%, is carbon capture. We can basically store the carbon that's created by energy, created by our industry, underground and under the sea. So that will really help things move along. But to put into context how much change we need to make, if we look at our current greenhouse gas emissions reduction targets, a new plan which was announced by the government in December is to reduce carbon emissions by 68% according to 1990 levels, yeah, by the end of this decade, so that's 2030. And it's hoped that this will help us meet our carbon reduction targets for 2050, which they were announced in 2019. And the idea here is that we will literally become, that we will reduce our carbon emissions targets by 100% relative to 1990 levels. We've made some progress. Currently, we have reduced emissions by about 43% compared to 1990 levels. But this was mostly done by switching to renewables. So we need to think at a local